Good morning, students. So, we are back on lecture number 5. Students, uh, due to some lack of information, the comments on my slide were off, but now I have turned on the comments. So, please leave your comments on the comments box so that I am able to get informed about your doubts and queries and some other problem if you are facing. So, uh, I'll be sending you the assignments of all the 5 lectures, and please go through these assignments. And I have mentioned the date of submission of these assignments. So please uh, do submit your completed assignments on my email ID. Thank you. So we start with the next topic. We are going to have the first topic that we are going to cover today is IoT, that is Internet of Things. Now, students, as we can see today, we are in the world of artificial intelligence. That means we can use the things which can perform by their own. It is quite related to this type of technology where we can use the internet technology for operating a normal device at our house, such as air conditioners, then some other things like toasters, like geysers, and refrigerators, and these types of things. They require some special type of hardware as well as software, and all these things we can control from our remote location without uh, being present at the device's location, and we can control all these devices with the help of internet. So internet of things is a network of physical objects or people called things that are embedded with software, electronic network, and sensors that allow these objects to collect and exchange data. So we are able to share the information or exchange the information with these types of devices. The goal of IoT is to extend the internet connectivity from standard devices like computer, mobile tablet to relatively dumb devices like a toaster. So, as I have mentioned uh, you know, these devices which can be controlled or which can use the technology of internet to operate, like our general devices or the conventional devices like computer, mobile phones, tablets, and other devices, to some devices which do not, uh, you know, uh, which are not, we cannot even imagine that these devices can be controlled through the internet. I would like to recall you that on the televisions we used to see an advertisement from Shri Amitabh Bachchan, where he used to control his AC sitting at a separate location or from somewhere outside, and he used to control the his air conditioner from uh, anywhere in the world through the help of internet. Similarly, on the CCTV cameras, we have the uh, you know advantage of uh, mm, having the picture and the controlling of the CCTV cameras from literally anywhere in the world. So IoT makes virtually everything smart. So we can make a normal devices to act as a smart device by improving aspects of our life with power of data collection, artificial intelligence algorithm. As I mentioned you that to convert a simple dumb devices into an artificial intelligent device, we need a certain amount of programming and some special hardware like sensors to read the commands, which can interpret the commands which are given through internet. The thing in IoT can also be a person with a diabetes monitor implant, an animal with tracking devices, etc. So we can not only control external devices, but we can control an embedded thing, something which has been put inside the body of a human being uh, uh, or an animal to track it or to operate some machinery which is fitted or embedded inside his body. Now this is the structure of the IoT technology, Internet of Things, which are used to control many devices like printers, games, and cameras. Then a lot of devices, you can see refrigerators, speakers, and so many devices, any devices which you cannot even consider that they might prove to be intelligent devices. Now the history of IoT. The history of IoT, it started in the year 1970, where the actual idea of connected devices was proposed. You know, the in 1970, the idea of connecting these devices with the help of networking was proposed. Then John Romkey created a toaster which could be turned off over the internet. Now you can see in 1990 the technology was so much developed that John Romkey, a scientist, was able to control his toaster from a remote location. In 1995, Siemens, it's a multinational company, uh, introduced the first cellular module built for M2M. That means, uh, you know, the Siemens company developed uh, the interface or the network which could communicate with the help of internet technology to a particular device. The term Internet of Things was used by Kevin Ashton during his work at PNG, which became widely accepted. Then a lot of research was going on through, uh, you know, in this technology by, Kevin Ashton, and this term, that is Internet of Things, was given by Kevin Ashton itself. In 2004, the term was mentioned in famous publications like Guardian, Boston Globe, and Scientific American. So a lot of articles were published in the various, world famous magazines. Then in 2005, UN's International Telecommunication Union (ITU) published its first report on the topic. So in 2005, the United Nations gave it a worldwide platform. That means an acceptability of to this technology. Then in 2008 the Internet of Things was born. So finally the acceptance or the recognition to the uh, you know technology was given in 2008. In 2011, Gartner, the market research company, include the Internet of Things technology in their research. Now in 2011, it was uh, included by the Gardner uh, uh, to study more about the technology and to enhance the technological research. Now, how does IoT works? Now, what is the way of working of an IoT, that is device? The entire IoT process starts with devices themselves like smartphone, smartwatches, electronic appliances like televisions, washing machines, which help you to communicate with the IoT platform. Here are four fundamental components of an IoT system. Now, any device, if it needs to be converted into a smart device, then what all you know, hardware or the software it would required to be known as an IoT device. The first of all, the sensors or the devices. Now, the sensors are the most important part of the IoT. These sensors are, they may be, sensing the internet or some special type of signals which are given by the user of the, the IoT device. And various types of sensors are there, like remote control or some internet control or the Wi-Fi sensor or some other type of signal sensors. Then secondly, it needs connectivity, the connectivity to some other device or to the network. Then, all the devices which are connected through internet, they need an internet connection. Mind uh, Mind you, this any device which is an IoT device cannot function offline. 24 by 7, it needs to be connected to the internet so that it can be, operated from anywhere. Then data processing. Once the data, that means the signal is being sent and interpreted by the device, then it comes to know how it has to behave further. So that is the known meaning of data processing. That means whatever data has been sent by the remote device to the IoT device, the data is being interpreted so that it is going to interpret what command has been given for the device. Then a user interface. There should be a user interface with the user of the device, where it can be able to connect to the device as well as to give various commands to the devices. Now, what are the applications? Where, in what field, for what devices do we need or do we apply the IoT technology? First of all, smart thermostats. Now, smart thermostats are these are a type of thermostats as we see in the microwaves. These thermostats are able to sense the heating temperature, and while whatever the temperature has been set, and they automatically are turned off by the smart technology. Then connected cars. All the cars, they have special sensors which are able to handle the billing, parking, insurance, and other related stuff automatically. So, if we can say that not exactly in India till now, but in the foreign countries, we can handle the billing and everything, every matter related to cars, whether it's parking or whatever. We want to check where our car is, or how is it. So we are able to identify it from a remote location, or we are able to uh, you know sense the cars uh, from the remote location. Then activity trackers. Now, the activity, it could be related to health. The all the activities which are related to health, they can it can be captured, like uh, rate of pulse, blood pressure, and some other things, temperatures, all can be studied with the help of these activity trackers. Then smart outlets. You know, all the devices can be, IoT devices can be used uh, in, uh, you know, um, um, using the outlets. Outlets means some stores or some retailers where which these devices can be used to inform you about a particular device or some other information through your smartphone. Then parking sensors. Then IoT technology help users to identify real-time availability of parking spaces on their phones. So these also help a particular car driver to identify where actually the parking is vacant at a particular time. Then connect health. Now the concept of connected healthcare system facilities real-time health monitoring and patient care to identify what treatment is to be given and his health and some other related issues regarding diseases and everything. They can be identified with the help of IoT devices. Then smart cities. Now the concept of smart cities, they can manage their traffic, their water distribution, waste management, etc. Then water management, and so many things are there with the help of this smart technology known as IoT. Then smart home. In the home itself, we can convert our devices to smart devices like smoke detectors, home appliances, light bulbs, windows, door locks, where we can start or turn off the device from sitting from anywhere in the house. Smart supply chain. Now, uh, you know, so, this technology helps you to identify the goods in transit and to find the real location of the particular goods in transit. Now, as we can see, this is a diagram which can tell you we can have smart homes, we can have smart transports like cars and everything. Then it is related to our body, that is health issues, temperature, diseases, and everything. Then infrastructure development and the smart cities. Now, what are the advantages of having an IoT device or the IoT technology? Now, the main of the advantages of the IoT technology is, the first thing is technical optimization. That means these devices are smart devices, and these smart devices are able to, uh, you know, uh, give a feedback to their vendors whether the device or the technology is working fine or not. And all these devices are capable of enhancing the quality of enhancing or improving the quality of these devices. Then improve data collection. The data collection at the devices end is quite improved in case of IoT devices, as you are able to uh, you know get the information in a real time. That means the latest information, the latest feedback from a particular device, you can have it at any point of time. Then reduce waste. Because of the real time you know information, there is an effective decision making and the management of resource. So as soon as you get the information or the data collection, then it is very easy to identify a problem or some other issues relating to it, and to timely design a strategy to overcome this type of problems. Now, improved customer engagement. Now, uh, this technology is able to improve the customer experience by detecting problems and improving the process. Again, it is the same thing, that the feedback from the user of the technology is given to the vendor or the seller or the manufacturer of the technology, and therefore he is able to improve the issues or some problems which are relating to the technology. Now, the disadvantages of having the IoT technology. The first issue is security. Now, the major issue for having this IoT technology is the security. Uh, Maybe some of the authentication or the authorization issues may occur to the end user of the technology, and this may create a problem. Then privacy. Now the IoT utilizes some amount of personal data where the data is passed over the internet, and therefore it can create a privacy issue. Then flexibility. Now the flexibility, you know, on this type of technology is not related only between two devices, but on the whole infrastructure which is involved in the internet as well as the provider of the technology. So the you know the working environment, the issues, the working issues of the vendor or the manufacturer of the technology may give you less of flexibility uh, in terms of using the device as per your conditions or your wishes. Complexity. The design of IoT system is quite complicated because it uses the artificial intelligence technology. So therefore, the programming or the technology itself is a bit complicated. And if any case, if the technology it malfunctions due to some reason, then it is very difficult to diagnose the errors, detect the errors in the technology, and then rectify to give it good results. Then compliance. Now the compliance means following the rules and regulations of the various sort of organizations uh, is quite difficult in case of IoT, because um, some country rules regulations may get violated, some privacy issue, some confidentiality issues may arise due to the technology, and which may be challenging in terms of law. Now the summary of the IoT technology, that is, the Internet of Things is a network of physical objects or people called things that are embedded with software, electronic network, and sensors, which allow these objects to collect and exchange data. So, the uh, mm, Internet of Things is a network of all the objects called things, which can be connected with each other with the help of this IoT technologies. The actual idea of connected devices was proposed in 1970, as we have studied about the history of IoT. So the idea of IoT was proposed in the year 1970. Now the four key components of IoT frameworks. What are the components of the IoT framework? That is the sensors in the devices, then the connectivity with the internet, then the data processing, that is interpretation of the signals, and then the user interface, the apps and some other types of interfaces to control these devices. Various applications of IoT are smart thermostats, connected cars, activity trackers, smart outlets, connected health. Then technical optimization, that is to uh, you know improve data collection, reduce waste, improve customer engagement are the key benefits of IoT. So these are the various benefits of having the IoT technology. So this is all about the IoT technology. We do not have of too much of the working of the IoT technology in detail, but the key components that are required as per the syllabus of IoT we have already covered. So we'll immediately switch over to the next topic, that is network protocols. So what basically are protocols? So in the world of technology, there are vast numbers of users communicating with different devices in different languages. So as we can see, that there are a number of countries who have their own languages, and they are trying to uh, mm, communicate with each other in their own languages. Now, that also includes many ways in which they transmit data along with the different software they implement. So every country may use a different software. Suppose uh, if I'm sending an email through Gmail, and the other person is using an Hotmail to interact. So these are the two different platforms we they use to communicate. So communicating worldwide will not be possible if there were no fixed standard. So if we do not follow a universal pattern of communication, it is very difficult for two people to communicate with each other, because everybody has or uses a different platform of networking. So this universal platform for working over a network is known as protocols. So, what basically are protocols? Protocols are the set of rules that help in governing the way a particular technology will function for communication. So, for communicating within a network or within networks, we have to have a common or universal platform where we can connect to each other and share the information. In other words, it can be said that the protocols are digital languages implemented in form of networking algorithms. So we have certain programmings, some algorithms through which we can create such protocols or platforms where all the different protocols or the platforms are converted into a universal platform. There are different network and network protocols users while surfing. So whenever you are working on a local area network or a wide area network, everywhere we use a different type of protocol, but the protocol is required to communicate in a network. Now, how network protocols work? How do these protocols work? Now, the network protocols break larger process to discrete, narrowly defined functions. Now, a huge amount of information is broken down into small chunks of information, and it is transferred or transited in the network, and this information is sent to the destination node or workstation in seven different types of layers, which are known as the OSI model, that is Open Systems Interconnection Model. Now, these open system interconnection model utilizes a certain fixed protocols under which a data is transmitted from one place to another place. Now there are several types of protocols, which we use in our day-to-day, handling of the network. The main protocol that we are using is the transmission control protocol and the internet protocol, that is known as TCP IP protocol. Then we have a user datagram protocol, then the post office protocol, simple mail transfer protocol, that is SMTP, then file transfer protocol, hypertext transfer protocol, then hypertext transfer protocol secure, then telnet and gopher. So let's study a little these protocols. The very first protocol that we are going to study is the transmission control protocol. The transmission control protocol is a type of protocol which is used to break large information into small uh, you know uh, pieces known as packets, and these packets are of equal sizes and they pass through the network with a unique packet number like 1, 2, 3, 4, 5, and so on. And these packets are delivered to the destination, and the TCP/IP protocol, same as it breaks down the uh, you know information into packets, it reassembles all the packets to form the information again. The next protocol is the Internet Protocol. The Internet Protocol is used for carrying the address of the destination node or the system. Now, it is basically known as an addressing protocol. It flows along with the TCP protocol, where it leads the message or the packets to the destination. So it is able to identify which route we have to choose to reach the destination. Now, Internet Protocol has two versions. One is the obsolete version that we do not use as of now, but still we have the option to use the this version of protocol. It is known as IPv4, that is IP version 4. Now, the IP version 4 was the first version of Internet Protocol. It was deployed, or it was used in the ARPANET, which we have studied earlier also. Now, the IPv4 uses a 32-bit address scheme, allowing to store 2 to the power 32 addresses, which is more than 4 billion addresses. Now, this type of protocol is capable of handling 2 to the power 32, that is a 32-bit address for each address. Now, till date, it is considered the primary internet protocol and carries 94% of internet traffic. So, it's still, as I told you, we have the option of using this protocol. So, it is quite utilized nowadays also. Now, IPv4, what are the various features? Connectionless protocol. It is uh, a protocol which does not require any sort of connection, allows creating a simple virtual communication layer over diversified devices. Now, this protocol is able to generate a unique address every time it is connected to a computer. It requires less memory and ease of remembering address, because of the length of address is so short. That is why it requires very less memory, and it is very easy to remember the IPv4 addresses. Now, already supported protocol by millions of devices. Now, IPv4 is the most supported devices which are working in a network. Now, offers video libraries and conferences. Now, this IPv4 is able to identify or connect two devices with the help of their addresses for the purpose of conferences or some video, uh, you know, conferencing or chatting. The next type of protocol that we use is the IPv6 protocol. It is the most recent version of Internet Protocol. So, uh, the current version of protocol that we use is the IPv6, which was, initiated in the year 1994. It comes with the 120-bit address space. That means it, uh, you know, is able to, uh, you know, handle an address of 128-bit length. Now, the features of IPv6: hierarchical addressing and routing infrastructure. Now, it has a whole sort of architecture, and where the systems are, identified, differently in a hierarchy. Now, stateful and stateless configuration. Stateful and stateless configuration means when when we are connected to an internet, or we are not connected to an internet, or we are connected to a network, or we are not connected to a network. So it may give you an address, uniquely a unique address, whether or not you are connected to a network. Now, support for quality of service. Now, again, the it is a reliable platform where we can transfer the information, an ideal protocol for neighboring node interaction. Now, this node, as I told you, that we don't need to be online to connect through this uh, protocol. So it is quite ideal to for the devices which are in a local area network. Now this is the addressing examples of IPv4 and IPv6, where you can see an IPv4 uses a 4 address scheme, whereas the IPv6 uses a wide length addressing schemes. Now UDP. UDP is the short form for user datagram protocol, where the UDP is a substitute communication protocol to transmission control protocol, implemented primarily for creating loss tolerating and low latency linking between different applications. Now this type of protocol is used where we do not have an internet connection, or the devices are lying in the same sort of network. UDP is an alternate for the TCP protocol, and it is used in the local area network. Now POP and SMTP, that is Post Office Protocol and Simple Mail Transport Protocol. Now the POP version 3, that is POP 3, is designed to receiving the incoming mails. All the incoming mails that you see in your inboxes are sent or received with the help of POP3 uh, protocols, whereas all the sent messages are sent with the help of the simple mail transfer protocol. Now the file transfer protocol. The file transfer protocol is used to upload and download a file. That means accessing or transferring a file from one machine to another machine in the network. So these transfer of files may be either uploading a certain file or downloading a certain file from or to a system. Now these files may include program files, multimedia files, text files, and documents, etc. Then hypertext transfer protocol and hypertext transfer protocol secure, that is HTTP and HTTPS. They both are same type of protocol. The basically HTTP is is a type of protocol which supports web pages which are written in a web language like HTML, and these um, uh, this protocol is capable of opening the information available over the internet for visual purposes, where the HTTP does not provide the secure authenticity of a website, whereas the HTTPS is a platform where it verifies the security or the authenticity of a secured website. That is the basic difference between the HTTP and the HTTPS. Then we have Telnet. Telnet is a set of rules designed for connecting one system with another. So Telnet is used uh, like a technology which is used to connect two systems for the purpose of exchanging information. Now these two systems, when they are connected, you know they provide you a remote login where you can connect to a particular uh, system with the help of some other machine. That, as you can see in the diagram also, that we have a telnet server and we have a telnet client. So this telnet client is able to access the information with the help of telnet server, that is a remote computer. Gopher. Now, Gopher is a collection of rules implemented for searching, retrieving, as well as displaying documents from isolated sites. Now, these are the protocols which are used to, access the information uh, from such websites where the information are not available on the public domain. Here, the information is reserved to be accessed by a certain group of people or some authenticated people only. Now, basically, the Gopher also works on the client server principle, where there is a server and a client, and the client requests the about the information from the server. Now, some other protocols which are used, uh, we do not need to read the in detail about these protocols. However, we need to know some of these protocols for the purpose of our exams. So ARP, that is Address Resolution Protocol, DHCP, Dynamic Host Configuration Protocol, IMAP4, that is Internet Message Access Protocol, SIP, Initiation Protocol, RTP, Real Time Transport Protocol, RLP, Resource Location Protocol, RAP, Root Access Protocol, L2TP, Layer 2 Tunneling Protocol, PPTP, that is point to point tunneling protocol, SNMP, that is simple network management protocol, and TFTP, that is trivial file transfer protocol. So students, this is the end of our topics, and so thank you very much, and please do comment on the lecture, and any if there is any problem, in the slides or in understanding, you can ask me your doubts, clarify your doubts with the help of your comments. So thank you, see you tomorrow.